Hello and welcome to this video on tannins. Tannins are an astringent polyphenolic molecule which is highly reactive. This binds to proteins and causes precipitation. This is good if you wish to remove amino acids from a brew. It's not so good for the taste though, as they generally have a bit of flavour and a rough mouthfeel. They also impart colour to red wine, and a deep red wine generally has greater concentrations. Tannins are found in tea, fruit and more. The tannins found in red wine are largely the condensed or non-hydrolysable form. As a rule, tannins exist between 50 and 300 molecular weight and size. This means they can be quite large and constitute a variety of shapes, sizes and structures. For brewing purposes, the ideal tannins are non-hydrolysable. This means that after they do their job, they will break down into smaller molecules which can be oxidized and removed or limited. In wine and spirits, tannins are mildly imparted from the wood that the beverage or wash is aged in. In wine, the soil the grapes are grown in can impart tannins to the fruit and as a result, the wine. This is one reason why certain soil types are considered better for certain grape cultivars. This leads to why tannins are present in red wine. Red wine is often fermented with the whole grape, skin, seeds and juice, whereas white wine is fermented after pressing and leaving only the juice, and as a consequence, very little tannin presence. This means that tannins as a whole are added in a larger quantity to red wine in the fermenting stage. This also leads to a larger quantity of non-hydrolyzing tannins being present in red wine. Once this is done, the wine is aged in oak, which imparts some hydrolyzing tannins to the wine. Tannins have a nominal role in the aroma of red wine when fermented with a non-Saccharomyces species. Tannins also reduce the effectiveness of Saccharomyces species as they bind with the yeast cell wall. This interferes with the cellular activity, metabolism and fermentation, particularly the metabolism of sugar and the incorporation into the cell. Tannins are important in wine for several reasons. The first is that they are a phenol, which helps to keep the wine from spoiling. Phenols prevent bacteria from growing to an extent. They also add flavour. This flavour, particularly the astringency, balances the sweetness of the sugars remaining in the wine. And finally, wine is often aged and tannins break down over time. This removes unwanted material, lees and flavours from the wine. This aging process removes the astringent flavour and creates a mellow taste. Tannins are the key wine preservation and the basis of the ability to engage in a long-term aging. As the wine ages, it forms aggregates in the barrel. The greater the tannin and the polymer content in the wine, the greater the aggregate size. This results in faster settling and removal of material waste as lees in the wine. This process of binding with proteins and other content of the wine is what gives red wine its density and body when consumed. A tannin-heavy wine will be astringent and bitter, whilst the conversely tannin-light wine will be flabby or overly sweet. The mechanism behind this is theoretically simple. The tannin binds with saliva, particularly the immunoglobulins, glycosaminoglycans, and other salivatory proteins, which in saliva create an aggregate in the mouth. This leads to a sensation of the physically aggregated mass. The same binding leads to a bowel upset in some people, as the tannins bind with digestive enzymes, preventing their activity. Finally, the tannins degrade in solution and have a higher affinity for sour taste receptors in an acid environment. In an interesting turn of events, ethanol seems to decrease the astringency effect of tannins. This is found in the underlying principle of changing pH and the disruption of hydrophobic interactions. This leads to a disruption of the aggregate structure. The alternative theory being that higher ethanol concentrations have a quasi-lubricative effect on the oral cavity. But the first is backed up by in vitro studies. The results presented show that the most acidic fractions of proteins had the ability to inhibit the formation of aggregates between the grape seed tannins and the two different salivatory proteins used. Finally, tannins have an interesting aspect regarding health claims. Whilst it is not as dramatic or overzealous as other phenols like resveratrol, it is likely only a matter of time. It has been postulated that ethanol could reduce the chemical interaction between proteins and red wine tannins. The present work suggested that alcohol seems to contribute indirectly to the antioxidant capacity of wine, by increasing the bioavailability of its phenolic compounds. However, this is likely to be very similar to resveratrol, in that although it may have some health benefits, they are unlikely to be in a large enough quantity to have an appreciable outcome in a clinical setting.